Uses of transformation matrices. Observe the figure. This one is reference frame A. This one is reference frame B. This one is reference frame C. Reference frame initially reference frame is coincides with stationary frame, world frame. This is the position vector of origin of frame B with respect to A frame, that is S frame, because of A and S coincides. This is the position vector arrow here, position vector of origin of reference frame C with respect to S frame, in S frame. This is the position vector of origin of reference frame C in B frame with respect to B frame, this one. Observe the orientation. This one is X, this one is Y, this one is Z. And the reference frame B, X, Y, Z. This orientation here is given by RSB 0, 0, 1, 0, minus 1, 0, 1, 0, 0. It is in the book, readily available. But how can we achieve this orientation? There are so many ways. One of the way is this. Initially, if we consider B frame is coincides with A, if we apply RY 90 and then after RZ 180, body fixed rotation, we will get orientation this. You have to check, you should check, you must check this. And this is reference frame C. The orientation of reference frame C with respect to S in S frame is given minus 1, 0, 0, 0, 0, 1, 0, 1, 0. We can achieve this orientation. There are so many ways, but one of the way, RZ 180 initially. If you rotate, if you consider C frame is coincide with A frame, that is S frame, world frame, and if you rotate, body fixed rotation around Z by 180 degree, and then after around X, body fixed rotation 90 degree, we get this orientation. This one, this vector has arrow here, this vector tail here, arrow here, this vector head here, here, tail here. A coincides with S. Transformation matrix of A in S is RSA, PSA. Similarly, TSB is RSB, PSB. And TSC equal to RSC, PSC. RSA, A coincides with S. So, rotation matrix is identity matrix 1, 0, 0, 0, 1, 0, 0, 0, 1. We have discussed RSB and RSC. Now, the location of the origin of each frame relative to S can be written. They have given. Again, I am repeating, the location of the origin of each frame relative to S frame can be written for PSA is 0, 0, 0 because of A coincides with S. So it is 0, 0, 0. PSB, that is origin of B in S frame. This one, this vector. It is opposite to that of Y. So we have taken, it is on Y axis. So X and Z 0, or we have taken for example minus 2, 0, minus 2, 0. And PSC, that is origin of C in S frame. It is this way. So it is in XY plane, but Y positive, X negative. For example, we have taken minus 1, 1, 0. Suppose. Since A is co-located with S, TSA, transformation matrix of A frame in S frame, constructed from RSA, PSA is the identity matrix because it coincides with S. Any frame can be expressed relative to any other, not just to S. For example, TBC. So transformations of C in B. It is denoted as RBC, PBC. Represent B relative to C. This wording I don't like, because of it is actually a transform matrix of C in B. So this is more comfortable sentence, that is, it converts points from frame C to B. It is more comfortable, this wording. RBC, rotation matrix of frame C in B. That is, if you want to convert a point from C to B, we will use this rotation matrix. They have given 0, 1, 0, 0, 0, minus 1, minus 1, 0, 0. But we have these RSB, RSC, etc., PSA, PSB and PSC. But how can we achieve this? We will discuss at the last of video. Here PBC is given 0, minus 3, minus 1. But how can we achieve this? Because of your data RSB, RSC, etc., PSB, PSC, using this we can obtain RBC and PBC. So we will derive it at the end of lecture. Now see here, vector addition. This vector plus this vector. Observe the arrow. Triangle law for vector addition. This vector plus this vector equal to this vector. But we will consider all the vectors in B frame. Again I am repeating, all the vectors in B frame, not S frame. So this is in S frame. This vector is in S frame. So we have to convert in B frame. Generally we convert a vector in B frame into S frame. But here the vector is in S frame and we want to convert in B frame. So we have to multiply RBS PSB, subscript cancellation rule, SS cut out, RBS PSB. So this vector is RBS PSB. This is in B frame, so no problem at all. So PBC plus PBC equal to this vector. This is also in S frame, so we have to convert in in B frame. So for this we have to multiply RBS PSC, SS cut out, subscript cancellation rule. So this is nothing but a vector addition, triangle law for vector addition after transformation, after rotation. But RBS is RSB transpose, because RBS is not directly given. So RSB transpose, RSB given plus PBC equal to RBS equal to RSB transpose into PSC, implies PBC subjecting PBC, this term here. So RSB transpose into PSC minus PSB. Exactly. Okay. See the figure. We have data is what? RSA, RSB and RSC. Moreover, PSA, PSB and PSC. Using this data and this figure, we want to find RBC and PBC. This one. So see here, RBC, RBS into RSC equal to RBC. Subscript cancellation rule. This one. We can cancel this. So notation is very useful. RBC. But we have not given RBS. We have given RSB. So RSB transpose, RBS is nothing but RSB transpose into RSC equal to RBC. Here by chance we have taken rotation such that by chance RSB and RSB transpose same, by chance, not every time. So RSB transpose is this and RSC it is given this. So we have written here, which is equal to RBC. If we multiply first row, first column, we get 0. First row, second column, we get 1. First row, third column, we get 0. Second row, first column, 0. Second row, second column, 0. Second row, third column, minus 1. Third row, first column, minus 1. Third row, second column, 0. Third row, third column is 0. See here, this is RBC we have obtained. It is the same as given in the book. This one. Now we want to find PBC. PBC, this one. In the textbook they have not given. We are obtaining using the formula PBC. So by subscript cancellation rule, see here, this vector plus this vector equal to this. But we have to consider all the vectors in body frame, this frame. Okay, this one is S frame. So converting this vector into B frame, we have to multiply RBS or PSB, SS cut out. So this vector as a whole is in B frame plus PBC. It is already in B frame, so PBC equal to this vector. This is in S frame. So here also RBS into PSC, subscript cancellation rule. Now RBS is RSB transpose into PSB plus PBC equal to RSB transpose into PSC. So subjecting PBC, RSB transpose into PSC minus PSB. RSB transpose, RSB is this, but its transpose here by chance its transpose is also same. So RSB transpose into PSC. PSC is this minus 1 1 0 and PSB is 0 minus 2 0. So minus 1 1 0, 0 minus 2 0. Subtracting this. So minus 1 minus 0 minus 1, 1 minus minus 2, so minus plus 3, and 0 minus 0 is 0, and this vector. So if we multiply first row, this column, we get 0. This into this we get minus 3. This into this we get minus 1. This is the same given in the book. 0 minus 3 minus 1. So we have cross checked. It is right. No arithmetic etc. If the vector, that is position vector, point is in B frame and we want to convert into S frame, then RS is RSB RB, which is equal to RS. But here the vector in S frame and we want to convert in B frame, so we require RSB transpose, and symbol is much helpful. So be careful about symbols.